All right, we're going to talk about slope now. When you think of slope, you all have had experience, I assume, walking up a hill. And that is the slope, right? Maybe you have to expend a little bit more energy, and then because the slope is higher, or it might be a gentle slope, so it's lower. And then you've gone downhill, same thing. You're going down a slope. So if you look at a hill, let's say here, when we want to measure how steep a slope is, we're going to look at how fast we're rising up versus going forward. So when you go up a hill, you're going forward, but you're also going up at the same time. The amount that you go forward is called the run, and the amount that you go up is called the rise. And the ratio between the rise and the run tells you how steep your slope is. So if you have a lot of rise but just a little bit of run, you're going to have a much steeper slope than if you rise just a little bit for a very long run. Okay, so it's a ratio. In other words, we take the rise over the run. Now, the letter that we use for slope is typically M. I don't know why it's M. Why not S? Well, S is used for other things in math, like distance. And it all comes from, I think, the French language. So I don't know why it's M, but remember that the slope is M. And here's a formula, but where that formula comes from is this ratio here, rise over run, okay? Now, let's look at the mathematical formula. y2 minus y1 over x2 minus x1. Well, where does this come from? This comes from 2 points in the rectangular coordinate system. So here we have the point x1, y1. And here we have the point x2, y2. And if you're just looking at the x values and focusing on them, the difference is the run. So as you travel from x1 to x2, in other words, you're moving forward, you're going to take this distance, but you want to get rid of, you want x1 to be your starting point, so you want to subtract x1 from x2 so that you don't count this piece right here. You're taking that away because this distance is x2 and this distance is x1, and so you subtract x1 from x2 to get this difference here, which is the distance from x1 to x2. So you take the difference, and that's the run in the denominator. Then to calculate the rise, you're going to go from this y1 height here, we're at a height of y1, and we're going to a height of y2. So the total height that we've gone up is y2 minus y1, because we want to subtract off this distance. We don't want to count that. We're starting here and rising to this point. So we take y2 minus y1. It's always important when you're doing this calculation to pick your points. It doesn't matter which one is point 1 and which one is point 2, but you have to be consistent. Once you've picked point 1 and point 2, y2 minus y1, x2 minus x1, you don't want to get those switched around. You can tell if you've done a proper calculation because typically if you make a mistake, it's a sign. So just remember that if you're going left to right and you're rising, your slope is positive. But if you're going left to right and you're falling, then your slope is negative. So lines slanted this way in the rectangular coordinate system have positive slope. Lines slanted this way in the rectangular coordinate system have negative slope. So make sure you check your answer and that it makes sense given your situation. So, and you might say, just think of when you're going uphill, it's positive. When you're going downhill, it's negative. You know, up is positive, down is negative. But you're always traveling from negative infinity to positive infinity, or in that direction. You don't want to go the other direction because then you're going to you might be going downhill, but because you're going negatively, it cancels out the negative and you get a positive slope. So be careful with orientation. Always go from left to right when you're looking at slope, and you're calculating x1 to x2, and then always go from lower to higher. So you're traveling from y1 to y2, so you're going to take y2 minus y1.